Diode logic. Let's start about diode logic. Diode logic is one of the type of logic families. In a diode logic, we use the diodes and the resistor. Here, this is the circuit diagram of diode logic. In this circuit, let's take VA as an input and VB is another input. This diode logic will behave as a NAND gate or NOR gate. Let's check. Let's suppose VA, I'm making a table of VA, I'm making a table of VB. Two inputs are there, that means 4 combinations will be there. 0001, 1011, here 00 means 0 input and 1 means high input. So what will be the output? Let's suppose check, this is diode DA, this is diode DB, okay. So let's check which diode will operate, DA, DB, okay. So whenever we give 0 input at VA, 0 means at the anode of DA diode 5 volt is given and at the cathode 0 volt is given. That means the diode will work. So diode DA will get on. In a similar way, diode DB will get on. So what will be the case when diode will get off? Whenever we give VA as high input. That means this will be on, but this will be off. Because if we give high potential at the cathode, then diode will not work. To operate a diode, we need to give high potential at the anode and low potential means negative potential at the cathode. So this will be your table. Now see, if this is the table, no, then what will be the output? If, now check first condition. Whenever we are giving 0, 0 input, then both the output are on. That means 5 volt, whatever the current produced by 5 volt will get synced. Will get synced through here. Okay, this is the way. Mouse draw. Will get synced from here or from here, because both the diodes are on. That means current will find a smaller level. Current will find a short circuit from here. But what happens when 0, 1 comes? If 0, 1 comes, then DA will give a path to flow a current, but DB will be off. But output will be 0. Because the whole value of current will pass from here, means 5 volt to VA. No current will pass to the output side. No current. So in this case, V out. In the first case, V out will be 0. In the second case, again V out will be 0. Why? Because current is finding a path from DA. In a third case, current will flow and got a path to flow from DB. And in fourth case, both the transistors are off. So the current has to flow to the output side. So in that case only, it will give the output 1. So tell me, in what manner this gate is behaving? Can you tell? Now it is behaving as an AND. So this is the way we used to define any kind of circuit working. Am I clear? Now let's talk about next gate. This is RTL circuit. This is a circuit of an RTL. Here, each diode will be replaced by a transistor, but the resistance remain the same. Here, it can be connected in a cascaded form. Let's suppose VA and VB both are as 0. So, both the transistor will not work. So, again, we will make a table like suppose VA, VB, and this is transistor QA and another is transistor QB. Okay, and accordingly V out. So 2 inputs are here. So 4 combinations will be 0, 1, 1, 0 and 1, 1. Now what will happen? Whenever we give low input to a transistor, then transistor will not operate. That means off. Again, this is off. This is off. Or whenever we give high input, that transistor will work. That means this way. So in this will get off. And again, it is on here. It is on here. Now, what will happen? Whenever both the transistors are off, then the current will not find any path and will go to output 1. When second condition comes, QA is off. QA is off. So path will not be found by this 6 volt. Then again current will flow to output. And again in a third condition, this transistor will be off, but this transistor will be on. So there will be a discontinuity between this ground and this main circuit. So again output will be 1. Now what will happen? Whenever both the transistors are working, then only the current from top to ground will flow. So in this case output will be 0. So at you can see this circuit is working as NAND. Okay, so this is this working of this circuit. See, this is diode transistor logic. In diode transistor logic, again the circuit will look like a diode logic. This is in this, the difference is this transistor. We are using this transistor. That's why this is known as diode transistor logic. This transistor you used to amplify the input, means whatever the power is consumed by the circuit, it will enhance that circuit. That's why it is faster than RT. This is the basic circuit. In a similar way, we can drive the truth table for these circuit as we have derived before. Clear? Now, this is ammeter coupled logic. This is the circuit of ammeter coupled logic. In this, these LL, this is showing low value, low. High means high output. So as you can see, this ECL circuit is giving 2 types of output, as OR gate and as NOR gate. In this circuit, we usually use to unsaturate the transistors, means negative supply it is used here. See, you can see this minus 5.2 volts. This is what? Negative supply. So ECL is the fastest of all logic families, and therefore it is employed in applications where very high speed is essential. As high speeds become possible in ECL, why? Because transistors are used in differential amplifier configuration. Later on you will know about this whenever you learn the analog electronics or some kind of electronic circuits, then you will know that what are differential amplifier configuration. In this, every transistor do not need to go into saturation. So the storage delay time is eliminated. So this is what the ECL circuit. These are the few characteristics of ECL circuit. Means it is having low propagation delay, means less than 1 nanosecond. So that's why it is the fastest logic family and operate on negative and positive both the supplies. So this is all about the logic families which are covered in this